One of the most powerful and also probably the most destructive things that physicists have discovered is nuclear fission and nuclear fusion. In 1945, in August of 1945, the only 2 nuclear bombs ever to be used against humans in warfare were dropped on the cities of Hiroshima and Nagasaki in Japan. I'm here in Hiroshima now, and behind me you can see the remains of one of the buildings, one of the only buildings in the entire city that was left standing after those bombs were detonated in 1945. Now, these bombs used enriched uranium, which is an unstable element, and the nucleus of that uranium is very unstable, and when it's hit by a neutron, that nucleus breaks down, it releases lots of energy, and it also releases 2 or 3 more neutrons, and those neutrons then go on to collide with other atoms or nuclei of uranium, and they continue to do that, more and more nuclei releasing more and more neutrons, and that is called a chain reaction. Now, when a uranium nucleus is hit by an incoming neutron, it undergoes fission, it breaks apart, and that produces 2 new nuclei. Which ones varies slightly, but often it can be a krypton and a barium, maybe krypton 93 and barium 140. And also, it releases 3 more neutrons. Now, each of those 3 neutrons then goes on and collides with another uranium nucleus. And each one of those undergoes fission and produces some more krypton and barium, but also produces 3 more neutrons. And each of those 9 neutrons then goes on and hits another 9 uranium nuclei and produces even more neutrons. And as you can see, this very quickly turns into a huge, huge number of neutrons and a huge number of these fission reactions. Now, not only does it produce 2 new elements, it also releases a large amount of energy, and that energy is in the form of a nuclear explosion. Now, you need a certain amount of uranium to make that chain reaction happen, and that certain amount of uranium is called a critical mass. Now, if you have not enough uranium, then those neutrons aren't enough to get that chain reaction going. Most of the neutrons leave the uranium and nothing happens. It just continues to decay. But if you get a mass of uranium that is greater than that critical mass, then that chain reaction happens very quickly. Imagine you only had a very small amount of uranium. Now, each one of these uranium nuclei might decay, but for the purposes of this, let's shoot a neutron into the middle of this block of uranium. Now, that's going to force this uranium atom to undergo fission, and it's going to release 3 more neutrons. Now, it might shoot off some neutrons out here. One of the neutrons might collide with another uranium atom. Even maybe 2 of them might collide with another uranium atom. And that would make these 2 undergo fission. But then the new neutrons from these ones, maybe one of them would collide with a new uranium atom, but most of them would leave. And then when this one underwent fission, most of these would leave as well. And that is not enough. We're losing too many neutrons here to sustain a chain reaction. Now imagine you have more uranium nuclei. If we introduce a neutron here, then when this middle nucleus undergoes fission, it's going to release some neutrons. Each one of those is going to collide with one of these hundreds of thousands of other nuclei surrounding it. They're going to release more neutrons. Each one of those is going to collide with another atom, and so on, and so on, and so on, until you get, very quickly, thousands of nuclei causing thousands of fission reactions, and then millions of nuclei causing millions of fission reactions, and that is a chain reaction. So you need a larger mass, you need a large enough mass to create this chain reaction. You need a mass that is greater than a certain critical mass in order for the chain reaction to occur. Now, the bomb that was dropped on Hiroshima contained 2 small amounts of uranium, and each one on their own was not big enough to cause that critical reaction. It wasn't quite above the critical mass. But when another regular explosive blew them both together, then they combined and they became easily over the critical mass, and that is what caused the explosion. Now, the explosion devastated an entire city. It killed, by December of that year, it had killed about 140,000 people, a lot of whom haven't even ever been able to be identified. The heat produced by the explosion reached up to 4,000 degrees. Almost anything that it came into contact with that was burnable spontaneously caught alight. The whole city started to burn. The pressure from the force wave was immense, something like 35 tons per square meter, just caused by the shockwave of the explosion. And the radiation damage that caused all sorts of cancers and stuff is still being analysed today, many, many, many years later. To me, this is a really powerful reminder that physics and the incredible discoveries that we make need to be used with extreme caution, and we have an enormous responsibility to make sure that nothing like this happens ever again.